gaze up at the night sky and see an endless expanse of twinkling lights that stretch from one end of the horizon to the other, each a distant star burning trillions of miles away. Stars are the architects of the universe, driving the cycles of creation, destruction, and transformation that shapes everything we see in the cosmos. Born in colossal clouds of gas and dust, each star has its own unique story, varying in size, temperature, and character. But what powers these celestial life-giving cosmic giants? What happens when their seemingly endless energy begins to wane? The answers lie in the extraordinary inner workings of stars, remarkable cosmic engines that are not only fundamental to the universe, but the very reason everything within it exists. At their core, stars are immense spheres of gas, primarily hydrogen and helium, held together by their own gravity. But don't let their simplicity fool you. They are marvels of physics and chemistry, governed by processes that have shaped the cosmos for billions of years. The life of a star begins in a cloud of gas and dust called a nebula. Gravity works its magic, pulling this material inward, compressing it, heating it, until the temperature and pressure at the center become so extreme that it ignites nuclear fusion. But what exactly is nuclear fusion? And why is it the key to a star's brilliance? Fusion is the process by which hydrogen atoms, under immense pressure and temperature, collide with enough force to overcome their natural repulsion and merge into helium atoms. This transformation releases an extraordinary amount of energy, which radiates outward as light and heat. This energy also counteracts the inward pull of gravity, creating a delicate balance that allows a star to shine for billions of years. But when this balance ends, the star will undergo an extreme transformation. A star's life is a battle between gravity and energy. During its main sequence, this balance remains stable, with fusion continuously replenishing the star's supply of energy. Our own sun is about halfway through its main sequence phase, steadily converting hydrogen to helium in its core. But this battle between gravity and fusion cannot last forever. Over time, a star exhausts its hydrogen fuel, forcing it to seek new ways to sustain itself. The result depends on the star's mass, setting the stage for its dramatic and varied fates. For stars like our Sun, the end is relatively peaceful. When hydrogen runs out, the core contracts under gravity, heating up and igniting helium fusion. This causes the outer layers to expand, turning the star into a red giant. In this swollen state, the Sun will one day engulf the inner planets, including Earth. As its fuel continues to deplete, the Sun will shed its outer layers, leaving behind a dense, hot core, a white dwarf. This stellar ember will slowly cool over billions of years, a faint reminder of the star it once was. But for stars that are much larger than our Sun, the ending isn't quite so subdued. Massive stars experience far more explosive endings. Their immense gravity allows them to fuse heavier and heavier elements, creating a layered core like an onion. However, when fusion produces iron, the game changes. Iron fusion consumes energy rather than releasing it, leading to a catastrophic collapse of the core. In a fraction of a second, the core is compressed into an incredibly dense state, triggering a supernova explosion. This event is among the most violent in the universe, scattering elements into space. It's this explosive scattering of elements that we owe our very existence to. The elements that make up planets, oceans, and even the human body, such as carbon, oxygen, nitrogen, and iron, were forged in the hearts of stars and scattered by supernovae. Without these cosmic forges, life as we know it would not exist. But the story doesn't end there. The remnants of a supernova can take two extraordinary forms: neutron stars and black holes. A neutron star is the collapsed core of a massive star, packing the mass of our Sun into a sphere just a few miles across. They are so dense that a sugar cube-sized piece of neutron star material would weigh billions of tons. If the core is even more massive, gravity overwhelms all forces, creating a black hole, a point of infinite density where even the fabric of space and time breaks down. But there is still one more type of star that is the most powerful and awesome object in the universe. A magnetar, the ultimate magnetic monster of the universe. These neutron stars are so intense that they defy imagination. They are rare celestial objects with supercharged magnetic fields 1 quadrillion times stronger than Earth's. A cosmic powerhouse with a gravitational pull so powerful it would spaghettify you in seconds. Get too close to a magnetar and its magnetic force will rearrange every atom in your body, shredding you at the subatomic level. They unleash bursts of energy so powerful that they can outshine entire galaxies, sending deadly gamma-ray pulses streaming across the cosmos. Magnetars are nature's ultimate reminder that the universe doesn't play by anyone's rules, but its own. While stars may seem eternal, they are fleeting compared to the age of the universe. Their lifespans ranges from a few million years for the most massive stars to tens of billions of years for smaller, cooler ones called red dwarfs. These red dwarf stars burn their fuel so slowly that they may even outlast the life of the universe as we know it, shining faintly into the future for billions, even trillions of years. Stars are more than just flickers of light in the evening sky. They are woven into the fabric of human culture and imagination. They have guided explorers, inspired poets, and served as symbols of hope and mystery. Every atom in your body was once a part of a star, forged in the intense heat of a stellar core. It is extraordinary to think that we are quite literally made of stardust. When we gaze up at the night sky, we're not just looking at distant suns, we're witnessing the echoes of creation itself. Stars are the architects of the universe, shaping galaxies, nurturing planets, and enabling life. They remind us of the immense scale of the cosmos and our tiny place within it. The next time you look up at the night sky and gaze at the endless expanse of stars, remember that they are more than just points of light. They all have a story to tell and are the cosmic miracle that allows everything else we see to exist. What other mysteries do these celestial wonders have yet to reveal to us? The answers, just like the stars themselves, are waiting for us to discover their secrets and quench the thirst of our curiosity. I'd like to thank you for joining us on our exploration of how stars work and invite you back for our next episode